This video will go over 2 examples of exponential functions with transformations. So if we look at this given exponential function, we see the graph down here. We can identify the transformations from the equation. So this positive 1, since it's with the x variable, it's going to be a left or right shift, a horizontal translation. Since x is left or right, it has to be horizontal. So the +1 actually is going to denote -1. So this is going to move 1 space to the left. And then we can see this number out on the end, the -2 is going to be an up or down, a vertical translation. And here's where the sign stays the same as what we would think. So this moves 2 spaces down. All right, our asymptote is that line that it's approaching at the bottom but not quite reaching. So if I see here, I can draw in my asymptote there. It's getting really close to this -2 value, but is never quite reaching it. So it is y equals -2. Another way we can see that is from our equation. That asymptote is that vertical translation as well. So that number out on the very end is going to tell you what your asymptote is. All right, the domain of these functions, well, the domain of all exponential functions is -infinity to +infinity. And we can see that because it goes to the left forever and it would keep going to the right forever. The range, thinking about the possible y values, well, if I go from the bottom to the top of the graph, I see that -2 is the bottom of the graph. But if I go up, this is going to continue up forever, so all the way up to +infinity. The y-intercept is where it intersects the y-axis, so I see that that is at the point 0, 1. And we can find that because the a value is 1. So if we look right here, there's no number in front, so it would have been a 1. All right, this is an example of growth. So this is increasing from -infinity to infinity. This is a growth graph. So there is no interval of decreasing. All right, and then lastly, we look at the end behavior. So as x goes to -infinity, so this is to the left side of the graph. Well, as it goes towards -infinity, it's kind of bottoming out at this asymptote, which was -2. So that y value is going to approach -2. As x goes to +infinity, which is to the right of my graph, as I go to the right, those y values are going up forever, so they're going to go up to +infinity. Let's look at one more example just like this. So again, looking at my transformations, this time I see a negative out front. So that is going to lead to a reflection over the x-axis. And then I see the number 2 in the front, so that's going to be a stretch. Where's my eraser? There we go. So a stretch by a factor of 2. That's how you could say that. And then if I look, there's no numbers up here or on the outside, so there's been no vertical or horizontal translations. Okay, now let's identify the asymptote. So since it didn't move up or down at all, there's no number on the outside. It's like having a +0. So our asymptote is just at y equals 0. And you can see here, if we draw this line, that's where it's approaching at y equals 0. Our domain, again, is always -infinity to +infinity. And if we write our range, this time from the bottom of our graph, it's pointing down. So it's starting down at -infinity. And as I go up, 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 It's getting all the way up to this x-axis, so at y equals 0, but is not quite touching it. All right, this time our y-intercept I see is right here. And again, remember that's from that a value. So it's 0, -2, and we can see here that a equals -2, so that makes sense. If I read from left to right across my graph, I will determine if this is increasing or decreasing. Well, this is increasing because of that reflection over the graph. Even though we're going to see that this is a decay function, this graph is actually increasing from left to right because it's been reflected. So it's increasing over this interval, and there is no interval of decreasing. So because the b value is 1/2, we see that up here in our equation, and 1/2 is less than 1, this is decay, but the reflection makes it look like growth. So just be careful to always refer back to the function. And last but not least, our end behavior. So as x goes to -infinity, that's the left side of the graph, I see that this is going down. So it's the y's are trending down to -infinity. And as x tends to positive infinity on the right side of my graph, those y values are approaching that asymptote of 0.